In our last lecture, we started to explore functions, both pre-written functions that are already built into Python and custom written functions that we are working on ourselves. So we looked at the syntax of functions and we looked at how to call a function. We learned how you can return values, or sometimes not, from a function, and we worked our way into a little bit of a puzzle. We created a function called fullName that simply concatenates two strings, and we saw that there were three variables here. There's a variable called first, there's a variable called last, and we said that those are parameters for the function, that they accept input from a caller. And inside the body of the function, we created another variable called name. What we discovered playing with the function is that these variables are not accessible outside the function. In fact, they don't even exist outside the function. So name has no existence out here in the interpretive shell. First has no existence in the interpretive shell, and neither does last. So these variables exist only inside the function, and they do not exist outside the function. Now that might seem weird at first, but this needs to become a commonsensical understanding about how functions work. And we call it variable scope. So let's take a further look at that. Let's take a little diagram of this. Let's imagine that our program is this kind of blue-green box in the back, and that the function that we're writing is a part of our script, but it is in the lighter green box, kind of in the front. Now, the color coding here is meant to signify that the program and the function, as it were, occupy different spaces. And in fact, when they have their own variables, those variables exist in that space. So when the function is called or executed, it creates these three variables in that space. And then when the function stops executing, when it hits the return statement, those variables are deleted. They even cease to exist. Now that's one of the reasons we can't see them. But the big reason is that Python is pretty protective of these different spaces, that it doesn't want there to be any contamination between those spaces. And we call this concept variable scope. And scope, it's related to things that we see, right? Like microscope and telescope. And what that means is that from Python's point of view, depending on where it is and where it's executing, it sometimes can or cannot see other functions. Now, as it turns out, this is a really good idea. So anytime we're inside that function, these variables first and last and name are created and they exist. Now, in fact, if we called that function 100 times, those three variables would be created and deleted 100 times. Now, even if this seems weird at first, this is a very, very good idea. And in fact, a programming language is really broken and broken badly if it doesn't do this properly. So this concept of variable scope is an idea, it's a concept that we really have to come to terms with, and it has to become part of our commonsensical understanding of how the programming language works. Now, there's a bunch of terminology here, and I'll give you a little bit of it today, but the concepts are what are really important. I need you to start to understand commonsensically and kind of intuitively, without having to think about it too much, how variable scope works. Now, one of the terms that we'll get is that these variables first and last and name, we might say, are locally scoped to that function. And that means that they exist only in that function, that they can be seen by Python only when Python is executing that function. Now, scoped variables that are outside that is to say in the dark green, that is to say in the rest of our program, we might call those global variables or globally scoped variables, which means that they can be seen all around the globe. They can be seen everywhere. So we're going to talk about that here in just a little bit. But there's this concept of local variables that is really the crucial part that we want to see first. Now, let's just take that one step farther and imagine this. Look at the dark black box first. So here in my global space, I've got a couple of variables. I got a variable first, I've got a variable last, and I am calling a function and I'm putting the result into a variable called name. So in that black space in my script, in the global space, I have these three variables, first and last and name. But now if I look at my function, look at what I've got in there. The two parameters that I'm receiving are first and last, and inside the function, I have a variable called name. So what Python does is it says, well, okay, when I'm executing that function, I am going to create new variables, first and last and name, that are scoped to that function. And you'll notice now what happens is that I actually have two variables called first and two called last and two called name. But because they live in different scopes, Python doesn't get them confused. And in fact, there are no collisions because I am not overwriting the global variables when Python falls into the function. So there are 6 variables in this script. It just so happens that 3 and 3 are in different scopes, so they do not collide and they don't overwrite each other. Now, we've seen a version of this before, which is the concept of a module. And we noticed that in order to access, say, math.py, we have to tell Python that it is in the math module, and there's a variable in there called pi. That's a really, really, really similar idea. And when we talk about that concept with with modules, we call those namespaces. So let's just imagine this kind of picture. Here's a script. If you can't obviously look at that and say, oh yes, this black box, clearly that's a Python script, obviously. So let's imagine that's my Python script, but now I'm going to start to do some work, and I'm going to do some work with modules. So I import module A. Now module A happens to have some functions inside of it, like function number 1 and function number 2. What happens is that all of those variables, and in fact the function names inside module A, are scoped to module A. And if in my black part of my script, if I want to tell Python to call function 1, I have to tell Python that it resides within module A. If I don't tell Python that function 1 exists in module A, it will say, hey, I can't find it. Literally, I can't see it. The same thing will happen if I import module B. Let's say there's functions 3 and 4 in there. I can't call function 4 unless I tell Python that it exists in module B. Now, module A and module B, the scope, if we want to call it a scope, is actually a namespace. So module A creates its own namespace. Module B creates its own namespace. And in fact, the black box of my big Python program has its own namespace. Now within those namespaces, function 1 can have its own variables that may accidentally have the same name as variables in function number 2, but they don't collide with one another because they have different scope. The same for 3 and 4. Function 3 and function 4 may use some of the same variable names, and in fact, module B may have some variables itself that aren't even in function 3 or function 4. But because they're all scoped differently, Python doesn't get confused, and these things won't collide with one another. And what that means for me as a programmer is that when I create my own function, let's say function 5 down here, I do not need to know anything about the variable names in module A, and I do not need to know anything about the variable names in module B, because namespaces and scopes keep everything clean. Now, this needs to become part of your commonsensical understanding of how things work. There's just no way around that. So if you happen to be looking at code and you're reading function 2, and then you're actually looking at function 3 and you're looking at the code, and you accidentally see the same variable names in both of those, in your head, there's no correlation. They're not the same thing at all. They're two different things. It's sort of like meeting two people named Bob. We don't get confused that they're the same person. The labels are the same. They're both named Bob, but we understand that they're different people, right? Or if we meet Sally, they're two different Sallys. We know that they're just different people that accidentally happen to have the same name. And it's a similar situation here in Python. Now, Python has one little wrinkle that maybe some languages don't do, which is that the dark green box here, my main script, cannot see any of the variables inside the lighter green box of the function. True. However, the light green function can see variables in the global scope. So the light green function here can in fact see a variable called location. It can use the variable called location. However, it cannot change the value of the variable called location. So Python is a little bit different. Not all languages behave this way, but Python is maybe a little bit different than some other languages in that the smaller scope can look out and see things in the bigger scope, but not vice versa. And the little scope does not have authority to change the values of variables in the big scope. Well, here we are in our text editor, and I've got my trusty terminal window behind me here. This is the code that we were just looking at, and I've dumped that into my text editor. I'm using Sublime today. But you can see up here at the top, I have that full name function. Again, parameters first and last. And you'll notice that I am using a global variable here. This is location, which I have defined down here on line 8 outside the function. The value of that is London. So here is our lesson that first and last and name are local variables to the function, but the function does have permission to look outside into the global space to see the value of location. It has permission to use the value of location, but we cannot write or change the value of location. We'll try and do that here in just a second. So over in my terminal window, I'm just going to do a directory listing, and you can see here's my my scope.py, and just for right now, I'm going to run this right here on the command line. So I'm just going to tell my operating system that I want to use Python, and I want Python to take as an input file scope.py, and we'll see what the output is. And you'll see I get actually William Shakespeare of London, which is pretty much what we would have expected to get. But now let me change this just a little bit. I'll put this back. Here's what I want to try to do, and this should give me an error, is I'm going to change the value of location, and I don't know, let's make that Sussex, a place in England. It won't let us do it anyway, but that's okay. And I'm going to make sure that I save that. All right, now here's what's happening. Again, same thing. Here, it will attempt, right, to use the global variable. However, it will not allow me to change the value of a global variable. And so what will happen is Python will say, oh, I see what you're doing. Location must therefore now be local rather than global. That is to say, it belongs to the function rather than to the rest of the space down here. And because I'm using it before I assign to it, Python will give me an error. Or it should. Let's see what's going to happen here. There's my error. So here's what it says. The name, first, last, plus location, but I get an unbound local error. The local variable location has been referenced before I have assigned anything to it. So again, it makes some sense. Even if that error message isn't necessarily completely logical or intuitive, but the rule is that my local function cannot set the value of a global variable. Therefore, this variable location must be local. However, I'm using it before I've assigned anything to it. And so Python is going to give me an error on that. All right. Sorry if we went down the rabbit hole of variable scoping a little bit too far there. A few more things that I'd like to play with before we're done for the day. Number one is that it's possible for us to give default values for certain parameters in our function signature. So here, for example, a version of the function we've been playing with recently here, if I, as the caller, send a string to the value first, or to the variable first, and if I send a string to the variable last, the function will use both of those arguments as I have sent them. However, if I choose to omit a value for the variable last, then the function has permission to substitute the string Shakespeare. So if I don't send a last name, it'll use the string Shakespeare. This is a really common practice, but there's one little hitch about it, which is that if I specify any default values in that parameter list, the default values have to come at the end. Otherwise, if I put default values at the beginning, Python would not know if I am omitting a value at the beginning or not. It just can't count the number of arguments properly. So the rule is any arguments that I specify automatically go at the beginning of that parameter list. And if I don't have enough, if I am short some values, then Python and the function have permission to substitute my default values. And we'll play with that here in just a minute. And in fact, we'll look at the print function as well, and we'll see some default values in the print function. Here's another option that I want to take a look at really briefly when we get to the command line again. It is possible for me to document what a function does. And we can do that in Python with a really cool thing called a DocString. A DocString is the second line here in this function. DocStrings are really funky and cool because they are triple quoted strings. And so here I've got triple quotes it says concatenate two names together. Now, why that's cool is because if Python is executing that function, it's basically a no-op, right? A no operation. There's just nothing for it to do. It's not an assignment. It's not a function. It just says, oh, here's a string that happens to be on this line. I'm just skipping it. However, when I get into the interactive shell, I can ask for help on this function. And when I ask for help, help will display the DocString. And you'll see down here at the bottom, I see both the signature and the DocString. So I can write my code in such a way that people can look at the signature and they can get some help that is built in to the function itself. These are great ideas, really good for the big projects. One last tidbit before we jump into the terminal window. The typical order for a Python program is to always put the functions at the top. There's a really good reason for that. But the typical order that we work in is that we usually have the import statements at the very top of our program, and that is followed by all of the functions that we're going to use, all of our custom written functions, and then that is followed by the program proper at the bottom. Now, the reason for that in Python is that we have to define a function before we can call it. And that's the reason that the functions go up at the top. Now, the more technical reason is because Python is technically what we call a one-pass compiler, as opposed to a two or a multi-pass compiler. So in other languages, what we would do when we run a program is that, like, well, let's just take PHP for an example, or JavaScript. One of those languages looks at our computer program and it goes through it one time and it makes a list of all the functions that we define, and it makes a list of all the variables that we're using. And then it goes through the program again. It starts at the very top and it starts executing from the top to the bottom. But it already knows where everything is. And that ain't Python. Python is a single pass compiler. So what happens is that Python starts at the top, but it only goes through the program one time. So if we use a module, but we haven't imported it at the top, we'll get an error because Python can't see an import statement anywhere else. If we declare a function that's at the bottom of our program, but we try to use it at the top, Python will give us an error because it hasn't seen the definition of that function yet. So this order seems, it might seem arbitrary or weird, but it really isn't. It's like you have to declare everything before you use it. And that especially goes for functions. And that's why they go typically at the top of the program. Okay, back to the terminal window. Here we are in the text editor. I've just put this last function in here, a couple of comments at the top. And so this is our full name, and you'll see I've got first, but I have a default value for the parameter last. If I do not send a value for last, the function will use the string Shakespeare. And you'll notice immediately after that, I have my triple quoted DocString, and that will be useful for a help if I ask for help, in which I will. And you'll notice that I have saved this into a file called tools.py. So if we just do a quick directory listing here, you'll notice that I've got tools.py here. Now, this is just a typical Python script like we've been writing the whole time, but here's what I'm going to do right now. I'm going to treat that as if it's a module. So I'm just going to get into the interpretive shell, and I'm going to say import tools, which it did. So now if I do a directory in tools, you'll see that I've got a whole bunch of stuff here, but here's my function full name. Like, wow, I don't know what full name does. What is that? So remember, tools now is a namespace. So every function, every variable, if there happen to be any in there, belongs to the namespace called tools. So if I want to get some help on the function called full name, I have to tell Python where it is. It is in the namespace or the module tools, and it is called full name. And there's my help string. So you'll notice that I do get, in fact, the signature, and so I can see that there is a value for, a parameter for first, and that the parameter for last has a default value attached to it, and my helpful DocString tells me that I'm going to concatenate two names together. That's great. Now, if you're in a Mac, you'll notice that it's kind of cleared the screen and it's waiting for me to end, so I just have to push the Q key on my keyboard to get out of that. I think on Windows, I think it doesn't clear the screen, but that's okay. You still push Q to get out of that. Now, if I want to use it, I have a thing I just pasted right here. I am going to call in the tools module the function called full name, and I'm going to send to it the two strings Ben and Johnson. And you'll see what I get back. No surprise there, right? But let's just take off that last one. So now I'm calling the function again, but I am not sending a last name, and now he becomes Ben Shakespeare. He's just joined a different family. So it's very easy to supply these. You can have as many of these default values as you want, but they have to come at the end of the parameter list. Otherwise, Python can't figure out where they go. All right. Well, that's it for experimenting with functions here in lecture 2, but we'll go on. We have much more to learn about functions in the future. So stay tuned.